Okay, hi everyone. My name's Ryan Dewar, and I'm joined here by Leo Karadimitris, and we have the great pleasure of hosting this really exciting presentation on embodied carbon for structural engineers. I want to extend a very warm welcome to all of you that have dialed in from around Australia and beyond. We've had an extremely high amount of interest in this event with around 200 registered attendees, so shows this topic is high on our collective agenda.
Hi everyone. Before we begin, I just want to take a moment to acknowledge the original custodians of the land we're all dialing in from, wherever that might be. For those joining us from overseas, we have a deep respect for the elders, past and present, as they have passed on knowledge and stories for generations. It is a privilege that we can all come together in this forum to also share knowledge and lessons learnt.
As many of you will know, the iStruct was founded in 1908 in a smoker's room of a fancy hotel in London, and it's now grown to be the world's largest membership organisation for structural engineers with 30,000 members globally. In Australia, we've got 606 members at last count, and the institution here, of course, provides lots of great tools and resources, as well as being an alternative pathway to chartership and an approved assessment entity for RPEQ here in Queensland. Today's event has been organised by the RG Queensland Regional Group. Whilst we haven't continued the tradition of meeting over a whiskey and a cigar, we do have a very active committee that organises CPD events and networking events all year round, including the popular exam preparation course. If you'd like to keep up to date with us, the best way to do so are through the regional group's page on the website. You can also subscribe to our mailing list or simply by following us on the LinkedIn page.
Okay, now let's get into the fun stuff. To give you an overview of what to expect in today's presentation, we will kick off with some introductions, then we'll hand over to Lucy and Cameron, our presenters, to talk us through all things embodied carbon in Australia and around the world. After the main presentation, we will have some time for Q&A with the speakers at the end. Just a couple of quick housekeeping items. Please keep your microphones muted as we go, and please encourage you to drop any questions in the meeting chat as they come to mind, and we'll get to them at the end.
Well, now it's a great pleasure to introduce you to our amazing speakers. First off is Cameron Archer-Jones. Cam is a passionate advocate for low carbon infrastructure designs that also balance cost, constructability, and safety. He has a background in structural engineering with a focus on bridges and offshore structures. He's born and bred Aussie, grew up on the Gold Coast, but he's lived in the UK since 2015, where he completed his master's and then went on to lead Covey's embodied carbon initiatives in the UK, amongst delivering a multitude of major projects around the world. Cameron now operates under his own company, supporting one of the UK's largest offshore wind developments. He sits on the iStruct Sustainability Committee and is a founding member of the Net Zero Bridges Group. He's published numerous papers on assessing and managing carbon and infrastructure projects, and he's dialing in today from London, so he's no doubt just settling in for his first early morning coffee.
Alongside Cameron, we have the brilliant Lucy Marsland. Lucy is a senior environmental designer at Atelier 10, located in Brisbane, and leads materials and carbon strategy on projects across Australia. With a background in structural engineering and now specialised in sustainable building design, Lucy has experience on major transport infrastructure, education, commercial and residential building projects. Through Australian and New Zealand industry leadership with MECLA, Lucy advocates for low carbon design, procurement and construction methods, and builds carbon measurement capability across the industry. Lucy was also one of the first NABERS accredited embodied carbon assessors in Australia.
And finally, before we hand over to the speakers, just like to add a little bit of context and emphasise the importance of the topic of embodied carbon. For those on the pathway to chartership, whether that be through the iStruct or Engineers Australia or another body, you'll need to demonstrate that sustainability has been considered in your designs. Those planning to sit the iStruct chartership exam in the future, there's also now a component of that exam that requires you to complete an embodied carbon calculation. But for all of us designing structures, the industry is changing quite quickly, and particularly for us Australians, the policies and client requirements are largely being shaped by industry standards in the UK. New South Wales government has just now mandated carbon management on all buildings and infrastructure projects over a certain value. And this will begin to trickle through to more and more states and other clients. So if it isn't already, embodied carbon management will be another essential part of the structural engineering design process. So please join me with a virtual clap to welcome the speakers, and I'll pass it over to you, Lucy, to get us started.
Thanks so much. It's a lovely introduction. And it's great to return to the iStruct Queensland Committee and Community. I presented, I think, maybe 2.5, almost 3 years ago, when I was earlier in my upfront carbon and embodied carbon kind of journey. Maybe some people are returning who recall that, and they may recognize some of my slides. So why are we here? I think, as Ryan really nicely laid out, carbon considered design is very much becoming business as usual for structural designers and all people contributing to buildings and infrastructure construction projects. Historically, it's all been about energy, that operational carbon, but now our sights are turning to the carbon associated with the materials and the assets we build. And together, those two big pieces of emissions will drive us towards these kind of global and local commitments to net zero that I'm sure everyone has heard about on the news and elsewhere. So we know that the Queensland government is committed to net zero 2050, as well as the Australian federal government. Not far off. And when we look at the building space, we see it even sooner, 2030, is where the Green Building Council is really mandating low carbon design being really a requirement, not a nice to have, and measurement being something that building projects need to stand behind. So right at the moment, if anyone isn't sure, when I say carbon, I'm talking about the emissions of greenhouse gases. And we know that our construction projects, all important, need to invest or spend or emit, consume resources and emit. They do emit greenhouse gases as a result of the processes upstream and also downstream of the construction stage that we all sit within. And that happens throughout an asset's life, so not just in construction, but also during the use phases and at the end of life. And so when we're imagining these inputs and outputs of the asset as a whole, we are talking about life cycle assessment. Where we want to be is less of this kind of linear consumption inputs and outputs, and more towards a more, there we go, special rainbow of more circularity in our resource use, which is, of course, more reusing assets as they are, more recovery, salvaging within construction, and recycling in the broader network, rethinking the way we design. So that's where we're trying to head to, and I think we're all on the path in the UK slightly earlier, perhaps, than we are in Australia, but we're accelerating at a rapid rate here in the ANZ region. So those lovely rainbow diagrams get a bit into more nitty-gritty detail with the technical language as defined by EN 978 for buildings and 17472 for infrastructure. These are our life cycle stages. If you take anything away from the bits that I talk about today, it's having this language of these life cycle stages. We spend a lot of time talking about A1 to A5, that upfront piece. And I think from a structural perspective, it makes sense, because that is the big chunk of the structural system is going to survive the duration of an asset's life. However, there's, of course, other pieces around maintenance, repair, replacement, and refurbishment that many of structural engineers on the call would get experience in. We know that the operational energy, the operational water, and for infrastructure, the user's utilization of the asset is a very significant portion of the greenhouse gases associated with a built asset. And then when we look at end of life, that C stage and onwards into the D stage, beyond the boundary, that is when we get to call this whole of life impact or whole of life carbon. So learn some of that notation so that we can all speak the same language when we're working on projects. when we're trying to get to these quantified emissions, we need to bear in mind that like many things in engineering, we are not necessarily looking at direct measurement, but we are working with estimates. We're working with the best available data to inform our design decisions. So the way we do that in this carbon measurement or life cycle assessment is that we apply a rate to a quantity. So it's not dissimilar to cost planning in some ways, except we're talking about environmental impact rather than dollars. So we need to know our quantities, whether that's a quantity of material, tons of steel, meters cubed of concrete, or if we're looking at the amount of electricity consumed in a year or the amount of diesel consumed by a crane on site. We're always working with those units of quantities. And to that, we apply a rate or an environmental profile intensity. This can be other environmental impacts, but today we're broadly talking about carbon or global warming potential, GWP. We find these emission rates or emission factors from environmental product declarations or from generic environmental emissions factor data, which we're going to talk about a little bit later in the presentation, both in the UK and in Australia. So that was your crash course in measurement. We're going to pick up some more of the nuances here. But of course, as I said, the measurement is to an end, and that is to reducing our impact on the environment through the designs that we all work on and deliver. So the measurement is critically important because what we measure is what we manage, and having that data driving our design is something that all of us with an engineering background are incredibly passionate about. So at the end of the day, we do want to, I guess, look to what can we do, how can we contribute to these projects, and at the bottom line is we want to use less stuff. We'll talk about some of the more detailed nuances of what that looks like in terms of digital optimization, good design, and different construction methodologies that can support that. But at the end of the day, we are looking to use this stuff. So try to let that anchor you when you're navigating the complexities of carbon, and keep that kind of North Star in mind. I'm going to hand over to Cam, I think.
Great, thanks, Lucy. Thanks again also for the introduction. So where I'm going to try and sort of link this in with best practice is coming at it from I guess a UK context. So if the first slide I've got here is just sort of looking at setting that context in a bit more detail. So similar to what Lucy introduced, the UK has a target to get to net zero by 2050. But I think there are some slight differences that have led to, I guess, a different speed of implementation, and I guess a different consequence of failure if projects get it wrong in the UK. So the target for net zero originally comes under the 2015 Paris Agreement, but I guess the unique part in the UK, or relatively unique, is that this was the sort of commitment that was made under that agreement was then enshrined in law in the UK with legally binding targets. And there's also then a group that sits behind and sort of assesses the UK government's performance or any project's performance against those targets. Is it compatible with getting to net zero by 2050? As a result, there have been some quite major project challenges. And I guess the big one that gets talked about quite a lot when you start talking about major projects that require a direct consent order or a TCO from the UK government is Heathrow third runway. So in 2020, the third Heathrow runway, which you can see on the top image there, that was a very mature project. They had been doing all sorts of detailed studies. They were at the point where they were starting to get full land sort of use rights and all those sorts of things. It was successfully challenged in the UK courts for having been found to be not compliant with the UK government's commitment to get to net zero by 2050. So that was a bit of a watershed moment for major projects in the UK. And then it led to a range of changes being implemented in project execution at all different levels for all different sizes. And I've picked out one more noteworthy project, because the project director for Heathrow Third Runway then pivoted across to Lower Thames Crossing, which is one of the largest proposed highway developments in the UK. And taking, I guess, the sort of lessons from that process, it helped really ingrain in a sort of a culture of carbon management in the project development. And that has come through in various different levels. At the highest, they have a clear commitment to meet a certain carbon target, both during construction and then in operation. But also the project's been designated as a pathfinder, which means that the government is sort of acknowledging in advance that they're going to spend a bit of extra money to see what the best possible outcome can be. That's probably massively oversimplifying the story, but I guess it is useful to set the scene and the context. And the result of, I guess, that plus a lot of other initiatives has led to all, or increasingly, a growing number of major UK clients that have clear commitments in their projects. And the client organizations being the one that funds the project is, I guess, one of the most useful levers that can be pulled to reduce carbon in construction. So that's the context. Now, in terms of, I guess, the sort of leading approach that's adopted for carbon management in the UK is documented in a standard called PAS 2080, which there's a little snippet of the front cover on the right-hand side there. So it's carbon management in buildings and infrastructure. The PAS is sort of it sits one rank below the equivalent of an Australian standard or an AS. So it's not a full standard, but it's one step down, and it sets out very clear and useful guidance for who does what with respect to carbon management when delivering big projects. So I've taken the use less stuff analogy and sort of created the link into the main carbon management process in PAS 2080, which tries to take, I guess, that overall philosophy and turns it into something a bit more rigorous, where it can be adopted across multiple different people and multiple different organizations at any stage of a project. I won't talk through this whole flow diagram, but I will come back to it quite a bit in the next few slides. The key to point out is that the end goal here is number 4, decarbonisation. And to get there, the standard sets out a process of sort of going around this loop of continuous improvement, where you're assessing your carbon at relevant stages in the project, monitoring, reporting, feeding into procurement, and then trying to improve. But in the middle is this integrating into decision making. And from the perspective of what the structural engineer, can influence, that's the most important step, in my opinion. And the smaller this loop is around the people that actually have control on the material sizes and specification, the better. So I think that sort of approach aligns really well with the iStructD's general philosophy that the structural engineer should be taking a leading role in doing the assessment and managing carbon on projects, because we have quite a unique oversight of material use, construction effort, as well as making sure we're still meeting the desired outcome. Just touching on the assessment of carbon, I think Lucy summarized it really well. It's a set of quantities multiplied by the appropriate carbon factor summed up over the asset you're looking at. If anyone on the call hasn't seen it yet, the iStructD have, in my opinion, the industry leading guidance document, which is this one on the left, how to calculate embodied carbon. And it also has a bunch of very, very useful flowcharts to sort of step out the process in a logical manner. But also it's written for structural engineers, so it's not expecting you to be completely literate in all things life cycle assessments and having detailed knowledge of environmental product declarations. It gives a set of useful carbon factors so that if you were on a project, you can complete a defendable carbon assessment at that stage. So the snippet at the bottom there is just one of many sets of tables that have some carbon factors for people to use. And it also covers all those life cycle modules that Lucy presented at the beginning. So it not only covers A1 to 5, it covers the B phases at C as well as D. So then, in terms of pulling out an example of an assessment, here's the sort of cover star from the presentation, which is a project that I worked on 3-4 years ago now. And this here is a snapshot of what the output of an assessment would look like for a bridge. I guess, coming back to this idea, you're sort of summing carbon over the asset. You then can break it back down into what makes up the asset and break it into foundations and superstructure. But usefully, with a view like this at the appropriate time, it can help inform the right decisions as the project's being developed. So again, on that same project, just presenting here, when the project was at an early phase, following the one of the UK sort of delivery models is the REBA stages. So REBA 3 is sort of a prelim design. When it was at prelim design, there was a clear motivation that it had to reduce costs. So there was a sort of value engineering phase. As a result of that phase, the quantities were reduced substantially, and we were able to track that while saving money or materials, and then as a result cost, it was a clear saving in carbon as well between one phase to the next. Then at the point where we were completing REBA 4, which is sort of getting near a detailed design, we were able to sort of look ahead and say, well, okay, if we can do a bit more on the material specification front, there's an extra 10% of saving that we can get from where we are now. And that, although wasn't completely sort of realized in the end, a decent chunk of that 10% was realized with no additional cost. So in this context here, the contract for the procurement of this bridge had no explicit provisions for carbon. It was more cost orientated. But within that framework, we were still able to find decent savings and document them as we went, whilst also saving cost. So that's one bridge. Now sort of expanding it out and thinking, if you're on a single project, that's great. You can monitor it as you go. But how do you know how your bridge compares to a different bridge? It could be in a different setting or a different span arrangement or whatever. So I guess another key part of how the PAS 2080 sets out carbon management is that you want to have a good benchmark. So although you could say, yes, my project saved 20% relative to where it started, how do you know your starting point wasn't already terrible? So to try and help with that, there's been a sort of growing source of data that's been published, and this is a snapshot of a series of COVID bridges where it looks at the total carbon. This is upfront carbon, so A1 to 5, in a series of bridges that had been worked on at the firm in the last sort of 10 to 15 years, maybe even a bit longer for some of these. So there's a scale, horizontal scale at the bottom. So sort of hundreds of tons, you're talking small pedestrian bridges or short span road bridges or highway bridges. Then as you start to get longer to longer bridges, you then have a real step change, and you're going up in an order of magnitude with each of these bridges as you move to the right. The bottom right being Mumbai Trans Harbour Link, which is, I think, 33 kilometers across the Bay of Mumbai. The smallest bridge on the left there is only about 12 meters long, spans between two buildings in central London. Having that data is useful, but again, how do you benchmark it compared to a new project? So there needs to be some way to normalize that. So taking that same set of bridges, if you then divide it by the planned deck area, then it gives a different view. So I might just pivot back between these two. So if you pick out, I always like to look at this small one here. Although total carbon very low, carbon intensity shoots over here. So I guess just to make it clear that if you're going to set a useful benchmark, it needs to sort of be geometrically normalized by the overall size of the bridge for it to be useful. Taking that concept a bit further, what we did within COVI a few years ago as well was then to sum up compile a set of those carbon assessments for a range of bridges in a database, normalize them, and then look at carbon intensity across a larger portfolio of structures. Again, the whole view here is to try and set out what does good look like. How can you set an appropriate benchmark at the beginning of a project? The result of which was a carbon rating system for bridges, and this rating system is published in the iStruct magazine. It's free for anyone to view. Don't have to be members, and this here takes that set of data and it creates a sort of a very intuitive color scale where you can immediately get a feeling how good is my bridge in terms of upfront carbon with respect to a full portfolio of bridges. This being that, you don't have to work for a firm like Covey to have this immediate feedback loop. So it provides something in the absence of anything else. But important to point out that it was calibrated such that the average was between a D and an E, that by 2030, the overall targets at a governmental level was that the upfront emissions in construction should be half. So the B is, I guess, the notional target for 2030, and then 2050 is net zero. So we want to get as low as practically possible. So that's, I guess, how the bars are set. In practice, this means that you could take a new crossing, like this example here, again, a Covey project where it was starting out as just a line on the page, and the project team adopted a target to begin with. So I guess in the timing here, the rating system came out a few years ago. This project kicked off after it had been published, and it was within the same office that myself and a colleague who developed the rating system were working. And then I guess it presented a really good example of how you can lock or you can adopt that target early with an appropriate benchmark for the structure type and use it to motivate the team generally to making sure we're making those right decisions. So I guess coming back to that PAS 2080 loop, it's really trying to make sure that decision making is the most appropriate for a specific project. It has also been applied on a project in Australia. So at Covey, we worked on the Maribyrnong Rail Bridge down in Victoria. Sadly, it eventually got postponed. But during it, I guess just to show this adopting this approach, it's very much, it has an international approach. So although your carbon factors might be slightly different, depending on where you're sourcing concrete or steel, the overall approach is completely universal. That whole idea of how life cycles are broken down and how to do an assessment, that's the same. And the example here on the right is from the general notes drawing, where we put on how we've done the assessment, what the current rating was, and we clearly stated what the target was, so that our client was clear and bought into this idea that we were trying to minimize carbon as well as minimizing cost, optimizing durability and safety and everything else that's important to a project. So just a few more from me. So that very much focused on upfront carbon, which is that A1 to 5 module. A couple other useful points when it comes to a sort of bridge design and bridge planning is that looking sort of across all the life cycles, because the sort of users of this infrastructure, it's a bridge will form part of a transport network. So the users on that network over time, over 100 years, their emissions, if it's a highway bridge, will be significantly greater than the bridge itself. This here, I think, important to caveat that sort of industry has its own targets and its own trajectory to decarbonize, and also the structural engineer has much less influence, but not no influence. We still have some influence in how this can be set out. The example on the left tries to show that. So if you're trying to get from A to B, when you're planning the route itself, you do have options. So the quickest route, the shortest route, which would then have the lowest emissions for vehicles, may end up with the longest structure. Whereas the one with the shortest structure, the one that goes right up to the top, although the bridge's carbon footprint will be much, much smaller than the straight option, your total journey increases. And at some point, depending on the traffic volumes, there will be a tipping point. So I guess the point I'm trying to make here is that having that whole life carbon view for the right stage of a project, like when you're planning out the actual routes itself, can be important to making sure, again, that we're making the right decision when it comes to managing carbon. The example on the right is a bridge in central Copenhagen, where it's showing that actually it's about, if you want to have a transport mode shift, you want to encourage more cyclists, then sometimes that can mean having a longer bridge that's more comfortable for a cyclist to use. And if that's the case, then we should be able to at least estimate the increase in cycling numbers by having better infrastructure for lower carbon transport modes. And then the last one from me is that I guess all the existing infrastructure we already have, when it comes to operating and maintaining, from the data that we have seen and assessed, certainly that maintaining the infrastructure we already have is definitely the lowest carbon way to manage a transport network. In a UK context, there's a sort of general view that most of the infrastructure we're going to need until 2050 we already have, so we should just be focusing on maintaining it. And I guess that context is very different in Australia. So I guess this is my segue back to you, Lucy. Thank you.
Thanks so much, Cam. It's really fantastic to continue to see the interaction between the UK and the Australian markets, getting those lessons learned across. And I think one of the things that I'm excited for is to hopefully see the Australian market increase transparency in between projects so that we can start to develop some of those amazing bar charts that at least I find incredibly exciting of comparing different projects to one another. And maybe some of the recent trends that I'm about to discuss will set the way for that increase and cross, I guess, different projects sharing their lessons learnt back into the market. So, as I said, I presented a couple of years ago to the iStruct team, and I had a sort of timeline of 2022, where are we heading, what's coming up, and now I get to provide an update on some of those things that I promised a couple of years ago, not that the industry as a whole has delivered. So we've really seen a huge amount of investment, consolidation, and acceleration in carbon measurement and carbon design in the past 5 years. Really pretty, to be honest, focused on upfront carbon. And that's maybe one distinction between the UK with a little more maturity. We are pretty focused on that A1 to A5, and in some cases even limited to the A1 to A3. But nonetheless, the focus on consolidation and kind of a shared consistent language, I think, is something that we have recently achieved after a huge amount of industry work, and is going to pave the way to that increase in transparency that we see in the UK. So the governments have been incredibly important, particularly in the infrastructure space. And then in the private market, in the building space, benchmarking and certification is probably the driving factor. The industry engagement has really upped, including through the likes of iStruct, and we're starting to see a couple of project pilots, or I like this phrase, pathfinder projects. But yeah, as I would love to see more shared in the industry. But I'll share a couple of examples that I have seen in the world. So starting with government guidance, this is really late 2024. We saw Infrastructure Australia building on Infrastructure New South Wales measurement guidance come out. And in some ways, they both refer to the PAS 2080 standard, and in some ways are trying to play a similar role in providing quite explicit direction about how to measure, and then providing supporting emissions factors to be used on projects. So you can, in terms of looking at the two regions, that's probably, we are at the beginning of having that consistent, quite specific standard for infrastructure that PAS 2080 has been providing to the UK market for a number of years now. These are available online. Infrastructure Australia versus Infrastructure New South Wales, it's fairly consistent, fairly aligned. And I think probably what I would reflect on from the Queensland context is that what we're seeing in New South Wales is what we would expect is coming to Queensland, because the federal government has picked up the work from the New South Wales context and brought it up to the Infrastructure Australia technical guidance. So as a Queenslander, it's worth getting across what is happening in New South Wales right now in order to anticipate what will come into the infrastructure space for Queensland. At the same time, looking at, I guess, less sticks, more carrots, we have the certification bodies kind of driving the design in a similar direction, but more from achieving a rating, achieving something that can be marketed by the project versus, I guess, being a policy-based approach. So for the building side, which is most of where my work occurs, we've just had neighbours bring out the embodied carbon measurement rating. It's called Embodied, but it is A1 to A5 at this time, so really it's upfront. But it again, for the building space, has that similar intent to consolidate and tighten up the way we measure to allow for benchmarking. And really what Neighbours is trying to achieve is a big pool of data of different typologies of buildings, different contexts, different ground conditions, different, form and height. And we know that these things all change the structural system and therefore the carbon of the design. They're trying to collect that pool of data. And so that's, hopefully I can come back in another 2 or 3 years and share the updates of what data comes out of the Neighbours initiative. The Green Building Council is fairly well known to anyone who works in buildings. They have been doing or rewarding life cycle assessment and more recently upfront carbon measurement for buildings projects. These are required by planning in a lot of the metro cities, including in Brisbane, as well as in Melbourne and across much of Sydney. And so that is, although it's voluntary, it's often a part of planning. And so maybe the thing that will come up the most frequently for you on projects. And then back to the infrastructure space, the ISC, the Infrastructure Sustainability Council, is the complementary body to the Green Building Council for the infrastructure application. Similarly, it has been rewarding life cycle assessment, so A through B5, measurement of materials. So in theory, there is data that's been collected over a period of time around embodied carbon, but it is behind walls, not necessarily in the market. For the Queensland government and for many of the state governments, an ISK rating is required on infrastructure projects over a financial threshold or a contract value threshold. So similar to the GBCA, although it's not a necessarily itself a policy lever, it is driven by state government requirements to be completed. So I think that what we will hopefully see, and we are definitely seeing this direction coming out in commitments to date, that the government guidance and these 3 certification bodies will all align in the measurement methods so that they're, regardless of so I guess you don't have to hold so many things in your mind, because I've just told you about kind of 4/5 different things. And what we're expecting is that in time this will really tightly align, or at least have a clear hierarchy. But for now, bear in mind that there may be a couple of different levers pulled that may bring you to measure carbon on a project in Australia. Looking at some of the industry kind of acceleration of interest and Australian local, I guess, thought leadership. As Ryan mentioned, I'm a part of the Materials Embodied Carbon Leadership Alliance, and so collaborate with different engineers as well as suppliers, as well as authorities across the country around driving down embodied carbon and materials. So the sorts of industry guidance, similar to how the iStructD supports structural engineers, the intent is to support everyone, and we see some of the supplementary, I guess, guidance to support that strict measurement protocols. So including the grading of concrete based on carbon intensity recently come out. Similarly, we have thought leadership around steel demand. And I know that this is similar, there are similar actions in the UK and particularly I was, and a lot of the parallels, I guess the principles are consistent. We know that steel demand everywhere in the world is on the rise, and the need to find more scrap is a bit of a challenge in order to drive down steel product carbon intensity. Similarly, with our concrete mixes, we know that our supplementary cementitious materials, our SCMs to replace cement and concrete, is also in high demand. And so as you get into a more sophisticated approach to carbon on your project, you will start to get a feel for some of the global supply chains that do definitely drive outcomes on projects, but also drive our global net zero, you know, our global mitigation of climate change. So one of the lessons from the industry is zooming out, I guess, looking beyond your particular project. Like Cam said, it's all well and good to reduce your carbon on your project from one stage to the next, but zooming out to what's happening around me on other projects, and then actually zooming further out to how is the construction industry contributing to our collective effort to mitigate climate change, which is really what we're here all trying to achieve, is to benefit our communities without harming future communities and future generations. So there's plenty to spruik from the Institute of Structural Engineers. I totally agree that the iStructD guidance, tools, publications are some of the most thorough, rigorous, and comprehensive across any industry. And you know, I'm a little biased because I like to think of myself as, you know, once upon a time having a structural engineering background, but it really is very impressive to see the quality of the guides coming out. So I really encourage you all to have a look at the tools, as well as the publications, both looking at carbon, but also looking at circularity, reuse as another complementary part of, I guess, our sustainability philosophy. I've got a couple of pilot projects. None of these are mine, so I'll just tell you what I know, but trying to give that infrastructure context, because I know that a lot of those on the call will be interested in the infrastructure space, and trying to give some context to what Cam presented. So in Australia, we don't have the lovely bar chart of lots of different projects, but we do have a couple of key pilot projects that the Infrastructure Australia technical guidance calls out to help support, I guess, someone learning to do this carbon measurement and also get a feel for where carbon sits on your design. So looking at a road project, we can see that on the left, similar ways of presenting data as Cam showed for the UK, looking at life cycle stage with that big A1 to A3 contribution, around 90%, smaller contributions for the A4 and A5 stages, and then also kind of flipping that and looking by material, and again seeing structures being carrying a lot of the responsibility, and that is something we really consistently see. We know that concrete, steel, the bones of our structures really are quite carbon intense, and so all the more importance for the structural engineers around us to have these skills to take on making that impact as a key decision maker, as Cam said. Looking at, I would love to see, I think, more of the style of industry sharing. So I hope to be able to show that in a future presentation. A different, I guess, angle on pilot projects is what were the design outcomes. So looking at my front door at the Cross River Rail project, which again, I wasn't involved in, this is kind of coming from what's in the public domain, but you'll see some real themes emerge in different states. So Cross River Rail, we see a couple of big levers being pulled around driving down the embodied carbon of the project. And mostly those are around material types and specific material products. And there is quite a lot of innovation occurring at the state government level infrastructure projects, including collaboration with the universities. So looking at the likes of crushed glass for sand, bringing in different, I guess, contributions to the to pavements, as well as sometimes you see into the concrete mix, which I'm sure plenty of people did honours thesis or master's thesis studies on. I know I did back in the day. We also see that on the Cross River Rail, there's quite a headline kind of initiative around diverting construction spoil away from landfill or away from needing to be treated towards creating bricks that can then be used across Brisbane, and that was at quite a scale. And then coming back to our SEM, our supplementary cementitious material, depending on the application, up to 60% SEM can be got into the concrete mix. Now, you'll definitely find that state by state, the state government specification guidelines will really govern that. And there's a whole another presentation probably around the nuances of concrete mix design for lower carbon outcomes. That could be an idea for a future talk. Moving states down to Sydney and looking at a building example, more from my industry, but getting to speak about the importance of retention, reuse of our assets. This is really, as I see, the only way we drive carbon down in a really meaningful way, below that sort of 30% reduction from business as usual. If we're seeking to get, towards that true net zero, we need to, as Cam said, be looking at the assets we already have. And so Quay Quarter Tower in Sydney is a really incredible example of extending the life of a tower through significant retention of structure and extending the overall amenity as well as the yield of the building through quite an innovative approach to adaptive reuse. So we do really need to see this happening as early as possible on projects. So when you enter a project on early days, confirming what the, I guess, existing condition is of a site, whether it is an infrastructure or buildings project, or if you're involved at, I guess, at the government side or the earlier client side, we really need to see this happen more. And we need to build the technical skills, I think, in industry to be able to solve the problems once you're doing a reuse project, because it is a fairly different skill set than when you're designing from scratch. So encourage, I guess, building those technical skills to help prepare us for this future. I've got my slides frozen now. That's okay. That doesn't matter. I was only bringing up Cam's image again of the importance of the structural engineer and that central decision-making nexus around the carbon assessment, and hoping that what we've presented today, I guess, gives you all some more motivation and some more skills to go and find more out about carbon measurement and how to apply it on your projects in order to integrate it into the design, into the decision making, and get it implemented in the end asset, hopefully, that gets delivered when they get delivered. So I think we're going to open for questions.
Yeah, amazing.
Now.
Thanks so much, Lucy and Cam. Yeah, I'll just do a quick conclusion and then we'll jump into some questions. But yeah, once again, a massive thank you to both of you. It's been really insightful and I think really exciting times for Australia. As you said, it's quite nice in a way to have the window into the UK and we can somewhat see into the future of what's coming here. And I think a key takeaway really is, the shift from embodied carbon being sort of kept in a siloed environment with some environmental or sustainability team to, that responsibility shifting to the structural engineer where the most influence can actually be made. So that's really good. Right, so before we get into some questions, I just wanted to draw everyone's attention to the iStruct resources in this sustainability spider web. We've already talked about that. There's heaps of stuff in there. It's really good quality and it's all free. So encourage you to have a little squiz at that and get familiar with it. And also, it's probably worth mentioning for any bridge engineers, encourage you to also take a look at the Net Zero Bridges group, which Cam was founder of. There's a bunch of great bridge specific papers and guidance notes in there as well. So yeah, let's kick off with some questions. Please drop them into the meeting chat. But whilst you're doing that, I do have one question for myself. I can see VJ's asked a question, and yes, the recording of this, we will package it up and distribute it around. Hopefully we can get it up on YouTube or something into the iStruct page, so that all of this great knowledge can be spread further, and you can pass it on to your colleagues and friends. But I'll kick us off with one question, and it kind of goes out to both of you really to just get your thoughts, but interested to get your thoughts on the effect of carbon factors in the future due to decarbonisation, green steel, electric arc furnaces, et cetera, sometimes we're faced with a decision to adopt a material with a longer design life, but might also come with a higher carbon intensity. Is there a case to err on the side of maybe shorter durability and design life with lower carbon factors in the hopes that, the replacement carbon in say 20 or however many years time might be much lower? Yeah, interested to get your thoughts on that.
I'll go first, shall I? I think, yeah, it's a good point. It's something that I've discussed quite a few times, because we inherently have ingrained in us that things we design have to be durable. They have to last the design life, and that's a sort of almost a foregone conclusion before we even start really getting into these sorts of questions. I think there is part of it where if you treat the climate emergency as an emergency, then maybe there is a shift to say, actually, should we be targeting something that just gets us to 2050, at which point then we can maintain it and replace it in a much more sort of carbon efficient manner. I think having that discussion on a real project, I think it would just really, really struggle. I think you would have to have a setup where it was almost like a modular structure where you could sort of design it for the bare minimum, assess how it performs in service, but with a clear way to, say, strengthen or improve or repair as needed in a very manageable way. I think we will still have that requirement to get to 100 years or 50 years, depending on the asset type. But I think how we get there, we could reassess, rather than it being just an upfront, we're going to build this thing and that's it. I think having something that follows its actual operational life and responds to what it sees is a way where you can try and get the best of both.
I would agree with Cam that it's probably not one or the other, but getting the right tool for the right job. And if you're going to go down the path of trying to extend design life, ensuring that you've designed it to be a valuable asset and to motivate that extension, because quite often things are not demoed because they're at the end of design life. It's because they're in the spot where someone wants to build something else, or the capacity, hasn't been future kind of proofed. When I worked as a construction engineer, I returned to a road bridge to duplicate the lanes 4 years after it was finished. So I think it's one thing to look at my materials, and I've built my T-beams and they're never gonna corrode, but if they're not ready for the community to use and they're not looking to that future, it's going to get demoed no matter how durable it is. So I think it has to be a really holistic outlook on that question.
Yeah, that's a really good example, actually, designing for widening in a bridge. Super common, but that is, it doesn't sound as sexy, but that's basically what we're talking about. That's how it comes into practice, having something that responds to the demand. It's like having a building that you can come and add a few more floors later if you need. There's a question around embodied carbon charts alongside cost. There's not a whole lot of data, unfortunately, that link the two together. There are a few good papers by a colleague actually in the Net Zero Bridges group named David Collings from Arcadis that has done a bit of cost and carbon data assessment. I think typically, like getting carbon data out, I find when I have discussions with people from other firms or with government agencies, there's a general acceptance that this is a sort of, best for everyone type of outcome. So there's a good reason to do it. Getting cost information out of projects is still very considered commercially sensitive, I think, to the point where it makes it a little bit difficult.
Cam, do you have any notes on steel reuse? You'd probably have deeper knowledge. I have some comments on it, but I'd hand it to you on any examples of steel reuse in your experience first, maybe.
Yeah, okay. For my own projects, all the best I've been able to get is a steel supplier that has a high content of scrap, and I guess the design decisions that can help that is using open hot rolled sections typically will lean itself better to an electric arc furnace production route, which then means you can use electricity as the source power, so it can be more renewable, but most importantly, you can use much higher content of scrap. So if you're specifying steel, if you start going for closed sections or principally sections that come from steel plate, they will typically come from a blast oxygen furnace route, which can't have as high recycled content because it can't have as high a level of impurities that the electric arc furnace route can have. So sorry, that's a bit of a long-winded way to say, I guess, not at the point I think where you're getting at, which is, can I reuse a steel beam as a steel beam? I've only ever used it where you're saying, can I maximize the or the sort of propensity to use recycled scrap in the manufacturing process? Good examples, though, there's the iStruct actually recently put out a steel reuse guidance, which I think also had a couple of good bridge examples in there. There's one that I can't remember the name of that a colleague at Net Zero Bridges Group worked on, and it'll go up as a case study very soon, that they were able to, I guess, explicitly source members from a scrap line before they got melted back down, and were able to reuse the beams as beams, i.e. sort of higher in that circular economy loop.
Yeah, exactly. I think I can give some Australian context, and I have also seen the fairly recent iStruct steel reuse guide, which is really great. And one of the key kind of headlines of that guide around reuse of, I guess, steel members without refabricating them. The hot take was, if the reuse of steel increases your overall tonnage by more than 30%, you may be better off getting steel recycled back into what is a kind of infinitely recycled loop for steel as a material. There is a according to the article, quite a clear threshold on when you are better off doing reuse with existing members if you've got I-beams in an existing asset, versus if it's going to increase your overall tonnage more than 30%, you're better off utilizing that industry. But it's really great, Cam, to hear. I hadn't heard that insight around an open section versus a closed section for a higher or more likely to use EAF. Yeah. There's a little bit of an Australian nuance in that we have a very small market around both rebar and structural steel. And so as a structural engineer, or really anyone on a project, you're not necessarily going to have a great lever to pull around specification, because it's a very limited market with a small number of suppliers being able to meet that. So highly constrained from a, I guess, market competition perspective.
Cool. Thanks both. I might just go through some more of the comments and questions. We've had one attendee say that the SCI has good guidance on reuse of steel design also, for anyone interested. There was a question there from Xenia. Where does quality come into this?
Yeah, I think I sort of mentioned similar things in terms of durability and safety, I guess, in a regular project development, I would put quality in that same section. It's sort of, that's sort of a minimum barrier to entry. And I think what we're talking about here is not reducing the target quality or reliability or durability of the asset that you're producing in the interest of saving carbon. What we're talking about is optimizing, or sort of, using your carbon most efficiently to get that sort of desired quality of the outcome.
Yep. Fantastic. Lucy, I just noticed there you've sent a link to Tim's question. So for anyone on the call also interested, Tim asked, does the iStruct-E have a good set of embodied carbon factors appropriate for use in Australia? Do you want to talk to that a little bit more, Lucy?
Yeah, well, I mean, I guess we've got, there's two things. I mean, Cam shared the PAS 2080 emissions factors that are, I guess, more UK Euro oriented, but are worth having in mind. The Infrastructure New South Wales embodied carbon data book is probably what I'd recommend for the Australian context. To use, particularly when you're at that early design stage where you're not necessarily talking about a specific product, you're just looking at design options, testing and optimization. That's a really good source from Infrastructure New South Wales.
Yeah, I'll jump in with another comment though. I think, again, with our engineering hats on, we can get really worried about what's the right factor to use. But if you're talking about the difference of 5–10%, if that stops you from doing the assessment at the right time, then you're doing something wrong. Like, the whole philosophy in the iStruct-E is having something that's approximate is much better than nothing, because we're too worried about, is my factor the exact right for the supplier? So I guess, irrespective of where the project stage is at, there are international averages that provide a good starting point. And again, I'd say it's not going to be the most accurate, but it's defendable in that it's reasonable skill and care, because that's the best of what the industry can do. So I think, we can go into a meeting with a client with confidence to say, I've based it on this. This is the best available information I have. And then, you sort of accept that, but at least you've got something to work with.
Yeah, I really like that point, and it probably segues well to the question Hayden's raised. And that, at what point should embodied carbon be considered in the size and scale of projects? In other words, single dwelling residential structures and upwards of low to medium rise structures. Is it worthwhile to consider the impact in the lower scale construction? And if it is, I'll just expand on that as well, because I had this thought, like, if it is worthwhile, what's the best ways to push that agenda when, the projects you want to make with the company you're in or your peers aren't necessarily geared that way?
Lucy, do you want to start?
Yeah, I'll answer the first part, and then I reckon Cam probably is going to have some good thoughts on how to, I guess, get more people on the journey. On the topic of, like, is the scale too small to consider it? What I've heard from and kind of learnt from some of my peers from MECLA, which do have a working group focused on the residential, like domestic detached house scale, is that the domestic house scale, while it's an individual house is a very small scale, that industry is huge. And actually, I think it represents much more of the construction industry kind of effort and also emissions, because of the, how many houses get built. And that is sort of amplified by the fact that the people working on houses, a single house, is a very different industry to those of us working on a bridge or a medium to high rise building. It's a different set of builders, it's a different set of designers. And so one of the key pieces is to bring that industry into the tent, particularly through the master builders and other kind of industry associations, to and embed carbon into things like TAFE training, so that industry is part of this conversation, because actually at the moment it's broadly not. A lot of the big wins are happening at that larger individual project scale, but the breadth of the domestic resi market actually, yeah, is a big hitter.
That's a good point. There's a terminology that's used for projects, and I think the question of scale depends on your perspective. So, like when a government in the UK considers some of these major projects, a lot of them have previously tried to slide under the radar of not being consequential to the country's emissions, with this thing they call salami slicing, where they sort of say, my project's this tiny little bit of salami, so don't worry about it. It's not going to make a big difference. But I think the analogy, it works the same way in your description. If you add all the salami slices of every single house, then you've got a serious packet of carbon that you're then ignoring because you're saying it's too aggregated, I can't do anything on it. So I think looping it back to the structural engineer, I would say, in the sort of office context, when a project comes in, if you're starting from the point where, say, your office or your team haven't done a lot of carbon assessments, nothing is too small. At COVID, when we were starting this process, we were doing carbon assessments of a pipe under a road, or we were doing it for, a drainage ditch or a retaining wall, as well as the big bridges. We were doing it for everything else, with this idea that you then build up a bit of an understanding of what good looks like. You don't actually need very many repeats of similar asset types until that feedback loop starts working really well. And you can start to see, okay, we've got 10 similar assets. I know that if I do a retaining wall with this type of arrangement, then I'm going to save some carbon. So at the beginning of the next project, you know that you're already making the right decision. So I'd say, like, building up the knowledge that we need as an industry to get better. At the moment, I'd say nothing is too small.
Yep. Yeah, really good point. Getting started is
Well,
is better than not doing anything.
Again, like the whole iStruct philosophy, which I'm obviously super bought into, is that if you hang around waiting for the perfect project, you'll never do it.
Yeah. Or to your point before, like finding those exact factors.
Exactly.
Which in many ways we're trying to
like,
search
yeah,
out.
I'm not saying ignore the strength of your steel. I'm saying ignore how accurate your carbon factor is for steel.
Fair enough. Well, I think at this point that comes to the end of the questions we have in the chat. If there are any more, drop them in quickly. Just I guess in the meantime, I'd like to expand on Ryan's thanks to both Lucy and Cameron for your hard work before this presentation, getting all the material together, and obviously presenting today to our group. We really appreciate it. Ryan, I think if your audio is back on, you might be able to help a little bit just on advice on sharing some of the information that was provided today.
Yeah. Well, as I said before, hopefully we could get the recording of the presentation and we'll distribute that around. And we've dropped a whole bunch of links into the chat there as well to various resources too. And they're kind of in amongst the presentation. There's lots of links too. But I think, as the guy said, it's all online, it's all free, it's all accessible. So it should be fairly easy. But yeah, once again, feel free to reach out to obviously our committee, the Queensland Regional Group. If you do struggle to find anything, or we can link you up with Cam or Lucy if you want to get their contact details and get in touch with them too. So yeah, great. I think, well, let's leave it there then, shall we?